Hi guys, it's Mrs. Mindy, and we're going to start talking about matter and specifically elements, compounds, and mixtures, and other ways of classifying matter. All right, now we're getting right into chemistry, and chemistry is the study of matter and its changes. And to make sure that you really know what matter is defined as anything that has mass and takes up space. And it may not just be the things that you might think of. So it can be any of these things. So it can be something squishy, and it can be a gas like this blowing this person's hair. It can be this cat, the liquid in this river, and this moss and rocks, anything that it has mass and it takes up space. Okay, so then what isn't matter? And there are a lot of things that aren't matter, but here are some. Um, if you think of any other ones, you can tell me and I'll change the slide for next time. So sound is not matter. It's a pattern of vibration moving through matter. Empty space is not matter. It has no, I guess you might think of space as taking up space, but you can't compress it. You can't, it doesn't preclude anything else from being there. That's what like taking up space means. Light has no mass and it doesn't take up space. Gravity, this isn't really gravity, this is the cat jumping, but gravity doesn't take up space. It isn't matter. It has no mass. Magnetic fields have no mass. They don't take up space. I mean, you can think about them, being in the space, but it doesn't keep anything else from being there by it being magnetic, except it'll repel another magnetic field. Also, computer programs don't take up space, and ideas, things like that. They take up so computer programs take up space on a hard drive, but we just say that the space is really there. The drive is there anyway. It's just it's kind of patterned inside there. Okay, some definitions. A substance is a single kind of matter or a bunch of one kind of particle altogether. So, like, this is a carbon dioxide molecule, so this is a substance together. And solid carbon dioxide or dry ice, that's still a substance. It's one kind of thing, okay? It's one kind of molecule. So a substance can change its state. It can be solid, liquid, gas, plasma, and still stay the same substance. So, like, the carbon dioxide that's bubbles in your soda pop is the same substance as the carbon dioxide in this dry ice. It's still the same stuff, the one kind of particle. So think about this then. Is a table a substance? Well, probably not. I mean, it depends on the table. I suppose if you had a table that was all like glass, even the legs and everything, then that could be. Or if it were, see, because not even stone is mostly not a substance because it's a mixture of things. Usually stone is different kind of stuff together. Not always. I guess if it could be if it's made out of a single kind of molecule, then it would be. But most tables are made out of wood, and wood is not a single substance. There's all kinds of different molecules inside wood because it was a living organism before. Or it might be made of plastic or plastic and metal. I guess if it were 100% metal, that would do it too. But usually it'll have like a table that's metal will have metal legs, or it'll have like a metal wraparound on it or something. So probably not. Look around at your table that is nearest to you and see. Certainly the ones in the science lab are not substances. Physical property. So matter has physical properties. And what we mean by that is that's a property that you can see or observe. You don't have to see it with your eyes. It could be like hardness or something that you could feel without the molecules changing. Okay? So it just is what it is, not how it changes into something else. So some examples of that. These are not the only examples ever at all. These are just examples. Are what color is it? What's its melting point? How flexible is it? And this is a flexible LED, so I thought that was cool. We'll put that in there. What's the boiling point of it? Uh, every different substance is different for these things. Well, some of them might be the same color. Okay, but boiling point and melting point, that's different for everything. A chemical property, on the other hand, describes a substance's ability to change into other substances. How likely is it? What does it change into? So, like, for example, does that substance rust or corrode? So, like the iron in this car rusts. So, rust means bonding with oxygen and it changes into a different substance. Okay. And it is very likely to do this. So, like iron is very likely to rust. However, gold in this old Egyptian piece, the gold is thousands of years old and it has not corroded. So gold is not likely. The chemical property of gold is that it is not likely to corrode. You can make it, but it doesn't do it by itself very easily. Does it burn? So because some things will not burn, and burning means combining with oxygen in uh, in a kind of violent way where it gives off a lot of light and heat. So does it burn? Some things do, some things don't. Some things will melt before they burn, and they won't burn. Like gold will melt, and it won't burn. How can you tell if something is a chemical property? So this is just a question for you to think, did I understand the last thing that she said? So a chemical property, remember, is how likely it is to change into a different substance. That's a chemical property. Or does it change in combination with this other thing? That's a chemical property. Okay, an element. An element is a substance that is made of only one kind of atom. Okay, only one kind of atom. So all of these structures, there's graphite and diamond and carbon nanotubes and fullerene and these guys, which I have blonde, I don't know what this one is. I think I looked it up once, but I don't know. And then graphene, which you can see is kind of like graphite. All of these different structures are made of the same kind of atom, carbon. Okay, so they would all count as elemental carbon. They're all just one element. Okay. Water can be zapped with electricity and broken into hydrogen and oxygen. So, is water an element? Think about that. Well, no, it can't be an element, even though, you can talk about elements as like an avatar. But that's the old-fashioned idea of element, and now we know that those aren't the basic elements of the universe, that we can break them down further. So if it can be broken into anything else besides its one kind of atom, then it is not an element because it's two elements bonded together. An atom is the basic particle of matter. It's the smallest amount of an element. So it's kind of a little bit circular, like an atom is the smallest amount of an element. An element is just made of one kind of atom. Okay. If you break it down any further than this, it's no longer meaningful. It's sort of generic matter. So, like, this is an electron. It's the same as any other electron. Okay. It's only in this combination of atom level that it has meaning as being an element with different properties. A chemical bond. A chemical bond is a link between atoms that connects them together pretty solidly. So they're not just close to each other, they're tied to each other. Okay? We show this bond. It doesn't really look like a little stripy cylinder like that, but we show it like that to show that it's different than just two atoms being near each other. A molecule is two or more atoms held together by chemical bonds. Okay? So this chemical bond is a link between atoms. A molecule is what you call the whole apparatus, the whole thing. So this is a caffeine molecule. And this is a hydrogen molecule. It can be as little as 2, it can be many, many thousands of atoms bonded together. So just 2 or more at least makes it a molecule. A compound is a special kind of molecule. So it's a molecule that is made of 2 or more different elements. Okay, so 2 or more different elements. So think about that, and let's go through these and say, are these compounds? Okay, so this oxygen molecule is 2 oxygens bonded together. So no, it's not a compound because these 2 are the same. A water molecule, it's 1 oxygen bonded to 2 hydrogens. Is this a compound? Yes, because it's 2 different kinds of atoms, oxygen and hydrogen. This hydrogen molecule, it's 2 hydrogens bonded together. Is it a compound? No, because it's 2 just the same. So it's not a compound. Here's part of a DNA molecule. It has lots of carbon, oxygen, hydrogen, nitrogen, and phosphorus. And it is a compound because it has more than one kind of atom in it. Okay, so if you've got a molecule, you want to know what's in it, right? And we use chemical formulas to write down what a molecule is, what it is made out of. So instead of writing, this is made of 1 oxygen bonded to 2 hydrogens, we just write it like this. And we'll talk more about this later. I just wanted to introduce you to it now. That a chemical formula, it will have letters, and it'll be a different capital letter for every different kind of atom that is in it, and this little number telling you how many of that kind of atom are in it. So 2 hydrogens, 1, 2, and 1 oxygen. Okay. There are also some elements that have a big letter and a small letter, but it's every time there's a new capital letter, that's a new element. Oh, I could have said that. All right. Oh, but that is a good, that's the thing I wanted to remember to say. It's good I wrote it down. So you can tell that this is a compound from the formula because it has different element symbols in it. So if it has different capital letters in it, you know it's a compound because it's different things. Okay, mixtures. That's another way of classifying matter. A mixture is 2 or more substances mixed together, but they are not chemically bonded. So that's different from like a molecule where they're bonded together. It's 2 different kinds of things. But this is different because they're just close together, but not bonded together. Okay? They're just, and how finely mixed they are is different. So, tea, it's water, and then the different molecules that are in tea. Milk has a lot of water, but it also has fats and sugars in it, and proteins in it too. Sand, you can even see the little different pieces that they're different. They have different properties because they have different colors and different hardnesses. They're made of different kinds of rock. Salt water is a mixture, even though you can't see the salt when it's all dissolved, but it's still a mixture. They're not bonded together. They're just very finely mixed. Chocolate has all kinds of chocolate molecules and fats in it, and milk that's put in it, different stuff. And then this pasta salad, you can clearly see the different things in the mixture. Okay, that's enough for today, and I will see you next time.